Okay, how to solve problem in chapter 2. As I mentioned before, three-phase diagram. The first, no-solid solution, limited solid solution, and also isomorphous. Step by step to solve problems. The first, find phase presence. Second, find composition. Next, calculate weight fraction or calculate weight amount or relative amount. This is the same meaning. Sometimes using a level rule. Okay. Next, draw microstructure. And the last one, draw and label cooling curve. Binary eutectic phase diagram, no solid solution. What is a eutectic? Eutectic is the composition of a mixture that has the lowest melting point, where the phases simultaneously crystallize from molten solution at this temperature. From the Greek eutectos, meaning easily melt. No solid solution, where the components are completely soluble in the liquid state, but completely insoluble in the solid state. For example, Plumben-Cooper system. Line C E E D we call as a liquidus. Above liquidus, L liquid. C F F E E G and G D we call as a solidus. Below solidus is a solid. Look, E we can call as a eutectic point, and this line is a eutectic temperature, TE. This line is a eutectic temperature. Now I divide by 2. For your left side, we call as a hypoeutectic, and for your right side is a hypereutectic. Right? So look here, liquid plus solid A, and for the hyper is a liquid plus solid B. Below solidus here, this region is a solid A plus with the solid B. Exercise. For an alloy containing 48% B, 60% A, determine the phase present, phase composition, and rate fraction of phases at a temperature slightly above eutectic temperature. So, make a straight line 48% B. Why 48% B? Because all this value here belongs by B. Second, find the temperature. This question gives you a sentence. Temperature slightly above eutectic temperature. You know, 363 here is your eutectic temperature. So, slightly above means here. Slightly above eutectic temperature. Present liquid plus B. So your first one is a phase present, liquid plus B. Second one is a composition. So your composition, you have the Cl, Cb and also C naught. First one, you can get the C naught from your initial point, initial composition, 40 weight percent B. So 40 weight percent B. Next, look here. This is a line liquidus. Line liquidus. So now this is your Cl, and for your right side is a Cb. Just take this value, 18.6 for Cl. So your answer 18.6 weight percent of B for Cl, and 100 here for your Cb. 100 weight percent B. Next, weight fraction. There are two phases here, liquid plus B. So you need to do a level rule. Make a straight line. This is your C naught. For your left side is a Cl, and for your right side is a Cb. Cl, you can get the formula for Wl, and Cb, you can get the formula for your Wb. So Wl formula Cb minus C naught over Cb minus Cl. So you just put all this value here to this formula, and then your last answer 74%. How about the Wb? Formula Wb, C naught minus Cl over Cb minus Cl. You just put this value, 40 minus 80.6 over 100 minus 18.6, you can get the 26%. Now, exercise 2. For an alloy containing 40 weight percent B, 60 weight percent A, determine the phase present, phase composition, and weight fraction of phases at 300 degrees Celsius. This question is very easy because temperature 300 degrees Celsius. So first, composition 40 weight percent B and also 300 degrees Celsius, and then you can get this region. So your answer for phase present is a plus B. A plus B. How about the composition? The composition here, you can get the Ca, and your right side is a Cb. Now you can get the Ca 0 weight percent of B, and Cb 100 weight percent of B. How about the CO? C naught here, or CO, is a 40 weight percent B. Now, weight fraction, you must do a level rule. So this is your level rule, C naught, and for your left side, Ca, and the right side is a Cb. So you can get Wa and also Wb. Formula Wa, weight fraction of A, Cb minus C naught over Cb minus Ca. So just put this value into this formula, you can get 60%. Wb formula is a C naught minus Ca over Cb minus Ca. And then just put this value for this formula, you can get the 40%. Exercise 3. For an alloy containing 40% B, 60% A, sketch and label the microstructure at a temperature slightly above eutectic temperature and 300 degrees Celsius. So for this question, there are asked to please find the temperature slightly above and also 300 degrees Celsius. Same as before, 40% B, slightly above. Slightly above is here. You can get the region is a liquid plus B, and also 300 is here. You can get phase present A plus B. Now we solve first slightly above eutectic temperature. You can get the answer liquid plus B. So make a circle here, and this is your liquid, and this microstructure is a solid B. Now 300 degrees Celsius. Your answer like this. Draw a lamella first. And you have the grand boundary. Lamella is a eutectic A. Here is a eutectic B. And this microstructure is a pro-eutectic B. Why pro-eutectic B? Because this is your hyper-eutectic B. So you can get the pro-eutectic B. How to draw cooling curve at hypo and hyper-eutectic alloy? So you have the temperature and also time. Temperature and time. This is a region liquid. Here, this is a region liquid plus solid. Either liquid plus solid A or liquid plus solid B. It depends hypo or hyper. And this is your eutectic temperature. And last one is your solid. Solid A plus solid B. This is a cooling curve for the hypo and hyper eutectic alloy.